for the interlude of interruption, but I know it was with my phone for you are still on, so we can continue. We were here. The LCM for the left-hand side becomes this. When I divide this with the sign B will cancel, so I will stay with the sign A cos B, and then I'll put a plus. When I divide this by cos of B, notice that the cos of B will cancel, then I will get cos. But we need to recall, when we look at what we have, and we recall that the sine of a double angle like B is 2 sine B cos B. Let me put it here. Sine of 2B is 2 sine B cos B. This implies that sine of B cos of B is actually equal to. This number is already complete. If we look at the numerator, it is complete. So we should be able to simply say that sine A cos B plus cos A sine B, we have noted, is the same as the sine of that expansion. So it implies that if we substitute for it, we shall have sine into A plus B over a half sine of 2B. In this a half will raise to give us this, and over sine of 2B, which we will simply say is equal to the right hand side as required. And we will have actually proved what they want. We will have actually proved what they want. So I want to challenge you that it is consistent practice that will actually help us to reach there. I therefore want to move to the T formula now. The T formula is what we are looking at. Now, for the T formula, we shall consider the double angles. We shall consider these expansions. Consider the expansions for sine of 2x. Sine of 2x, we are all aware that it is 2 sine x cos x for double angles. And we are also aware that cos of 2x is the same as cos squared x minus sine squared x. We are aware there are other expansions for this particular one, but mainly we shall look at these two. We want to express this. Our need or our objective, our need is to express the above in terms of tan x, in terms of tan of x. This is our desire, to express the above in terms of tan x. And how do we do it? I'll start with sine of 2x, and I want you to watch carefully because this is common in exam as a proof. We have said this is the same as 2, the sine of x, the cos of x. We can prove this to this effect by now. I believe you can prove that this is that. If you say it is the sine of x plus x on the left hand side, you expand it to eventually give you this in one step or two. So we can choose to play around with this and say that we can write this as 2 sine of x over cos of x, because we intend to bring in this, times cos squared x. I'm writing it like this because if I choose to cross this which I have introduced, this one and this one is still going back up. So I have not changed the expression, but I'm trying to bring in an element of tan. And if I proceed, I can write this as 2 tan of x times, since this is cos squared, I will write it as 1 out of sec squared x. 1 out of sec squared x, with an argument that